Hello everyone, and welcome to the video that I've made on graphing equations. This is again another skill review video. So our skill objectives for this particular video are 1, calculate the distance and midpoint between 2 points. Number 2, graph an equation by plotting points. 3, using intercepts and symmetry as a graphing aid. And 4, graph circles. And the conceptual objectives expand the concept of a one-dimensional number line to a two-dimensional plane and relate symmetry graphically and algebraically. First thing we have here is the distance and midpoint formulas. The distance formula is this one right here. The midpoint is here. We're looking at the distance between these points, general points P and Q. These are formulas that you should know. Make sure that, especially the distance formula, make sure you remember that one. The midpoint one is fairly easy to remember. If you just remember, it's just the average of the x coordinates and average of the y's. So in this case, I want to find the distance and midpoint between the point P, which is at -3.7, and the point Q, which is at 110. So using the distance formula, PQ, which is the distance from P to Q, equals the square root of 1 minus -3, that quantity squared, plus 10 minus 7, that quantity squared, which simplifies to 4 squared plus 3 squared. So I get the square root of 16 plus 9, which is the square root of 25, which equals 5. The midpoint, again, the average of the x's, average of the y's. So in this case, average is just the sum of the two divided by 2. So it's going to be -3 plus 1 divided by 2, and then 7 plus 10 divided by 2. And so our midpoint is the point -1, and then 17 over 2. You'll notice a lot that I keep fractions as improper fractions. I would suggest you do that as well. Do not make them into decimals. If you're required to get an exact answer, you do need it as a fraction. And I never use mixed numbers. I always keep it as improper fractions because if I'm going to need to do calculations with it, it's a lot easier when it's an improper fraction. Next thing is going through and graphing an equation by finding points. Now the trick to finding points is identifying which variable you want to plug numbers into. So in this case right here, when I look at this, I see I have a y squared. So I'm going to plug things in for y. It's going to be easier for me to put numbers in for y and determine x than to go the other way around. So when I'm going to put the numbers -2, -1, 0, 1, and 2 in for y, and when I do that, I get these values for x. And at this point, it is now just going to be plotting the points. So in this case right here, I have the point. This gives me, right here, this will give me the point 3, -2. So I go to 3, -2, over 3, over to 3, down 2, I get to this point right here. The next point is 0, -1, so 0, and then -1, and then -1, 0, 0, 1, and then 3, 2, and I get this parabola that opens to the right. Two things that we have that can often help us a lot with graphing is intercepts and symmetry. Intercepts are the x-intercepts and y-intercepts. The thing to remember there, when you're trying to find x-intercepts, you're going to let y equal 0. And when you want to find y-intercepts, you're going to let x equal 0. So in this case here, I want to find these intercepts, the intercepts for y equals x squared minus 4. So to find the x-intercepts, I put 0 in for y, so I get 0 equals x squared minus 4. So when I solve that for x squared, I get x squared equals 4. And so x, we know, is going to be plus or minus 2. So I have two x-intercepts at -2, 0, and 2, 0. The y-intercepts happen when x is 0. So I just put 0 in for x. So I get y equals 0 squared minus 4. So y is -4. So I have one y-intercept, and that is the point 0, -4. But that's always what you're going to do whenever you're trying to find the x or y intercepts. The other thing to do that you want to check for is symmetry, because symmetry gives us a nice aid. And there's 3 symmetries that you're going to be concerned with: the x-axis, the y-axis, and the origin. When it's symmetric with respect to the x-axis, it's like flipping over the x-axis, or think of it as the x-axis as a mirror. Okay, mirror image on the other side of the x-axis. Same thing when it's symmetric about the y-axis. It's going to be just flipping over the y-axis. Now, when it's so symmetric about the origin, some people think of that as a double flip. It's flipping over the y and the x. Other people will think of it as a rotation. So it's going and rotating 180 degrees, and it ends up right over there. So now the key thing that you have to keep in mind with symmetry is what you see here and here. In terms of it, when you have different types of symmetry, that also tells you things about points. So if I know, in this case right here, we know that the point AB is on the graph. If AB is on the graph and it's symmetric over the x-axis, then A, opposite of B, is going to be on the graph. If it's symmetric about the y-axis, then the opposite of AB is on the graph. And if it's symmetric about the origin, then the opposite of A, opposite of B is on the graph. What that means is that if I know if this point up here is, let's say, -3, 2, if that's -3, 2, if we're symmetric about the x-axis, then I know that the point -3, -2 is on the graph. If it's symmetric about the y-axis, I know the point 3, 2 is on the graph. And if it's symmetric about the origin, I would change both signs. So I'd get 3, -2 would be on the graph. The other thing you have is the test for symmetry. To test for symmetry over the x-axis, you replace y with the opposite of y and simplify it and see if you get back to the original. If you do, then symmetric over the x-axis. If it's to test for symmetry over the y-axis, you replace x with the opposite of x and simplify it, see if it looks the same. If it does, then it's symmetric to the y-axis. If you go through and replace x and y with the opposite of x, opposite y, and you simplify it, it gets back to the original, then you know it's symmetric about the origin. Now, the other thing you have, just kind of a jump ahead, later on we're going to be dealing with functions. Functions are never going to be symmetric to the x-axis. The only types of the symmetry of these three that you're going to have to worry about with functions is going to be symmetric to the y-axis and the origin. And that's something we will be discussing shortly when we get into chapter 1. Down here, you see an example of a symmetry test. We're taking the same function here, y equals x squared minus 4, and we want to check to see what symmetry it has. So I replace the x with the opposite of x. So the opposite of x squared is just going to be x squared minus 4. So you see when I simplify it, I got back to the original. The other ones won't happen. If I replace y with the opposite of y, I'm still going to have a negative sign, and I will not be able to get back to the original if I do that. So in this case, I know when I looked at this, I was only really checking to see if it was symmetric to the y-axis because I knew it wouldn't work for the others. Last thing we're looking at here is the equation for a circle. Now the standard form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. The center is always the coordinates hk. So whatever this h is and k is, that's going to be the center. The radius of the circle is equal to r. So when it's in that form, so I have an example here of x minus 3 squared plus y plus 5 squared equals 16. Notice it's x minus h and y minus k. So the sign for h and k here will always be the opposite of what you see here. So in this case, the center is going to be h is 3 and k is -5. So I know the center is at 3, -5. And the radius squared is 16, so the radius is equal to 4. Another circle that you should be familiar with and you've seen before is the unit circle, which the equation for that is x squared plus y squared equals 1. And that is going to be a circle you might remember from Algebra 2 where you worked with this in trig. We'll end up using that quite a bit there. So with that, this does conclude this video on the graphing. So if you have any questions, make sure to ask them in class and we'll see you then.